This is the lesson for section 11.2, which talks about the ambiguous case. Now, if you recall from chapter 10, we discussed how every trig ratio works backwards to two angles that give you that ratio. In the case of sine, these angles can be in either quadrant 1 or quadrant 2. And when we're talking about oblique triangles, we can have angles that are either in quadrant 1, which are known as acute angles, or we can have angles in quadrant 2, which are known as obtuse angles. And the problem is that if you do this inverse process, your calculator is only going to give you answers or angles in quadrant 1 when the values are positive. And this is because your calculator is set up to only give you one answer. It's set up to deal with functions, and there is a restricted range, in this case, for outputs. So it's possible that when we do the law of sines, we might not necessarily get the triangle that we're looking for. And so this leads us to what is known as the ambiguous case, which can either produce one or two triangles, or if there's been a mismeasurement or misinformation, then it's possible that you can end up with no triangle produced by the given information. So the first thing we always want to do is draw a picture and label it. Typically, this case, side angle, I put the angle down here, I put the opposite side, and then the other side given, just so we can have a standard to kind of reference when we're trying to go through the process of determining how many triangles we have. So first things first, you determine if this is your case. If you've got angle, side, or angle, side, angle, then you don't have to worry about it. But if not, then you have to ask yourself, do you have side, angle? And if so, then you need to look at this ambiguous case, which what we're going to do is we're going to find the height, the minimum this would need to be a right triangle. And then we're going to find this by taking the adjacent side, in this case b, times the sine of the angle given. And what we're going to do, we're going to ask ourselves several questions. Once we calculate h here, we're going to look at our opposite side, and we're going to ask ourselves, is the opposite side greater than the adjacent side that is given? That's the first thing that we're going to ask ourselves. If the answer is yes, then we have one triangle. If the answer is no, then we need to ask ourselves a second question. We need to calculate h, and we need to ask ourselves, is the opposite side greater than h? If yes, then we actually have two triangles. If no, then we have no triangle. So kind of a way to remember this is if you get that first answer to be yes, you've got one triangle. If your answer is no and then yes, you've got two different answers, which gives you two different triangles. And if you get no for both of them, you have no triangle. So let's look at what's going on here. If we have the case of one triangle, let's ask ourselves these questions first. Is the opposite side greater than the adjacent side? In this case, opposite side is 10. Is that greater than 6? Yes. So in this case, we have one triangle. We don't have to worry about calculating h. Again, all h is doing here is determining, if we drop this perpendicular down, what would be the minimum length we would need to get a right triangle. And since the opposite side is bigger than the adjacent side given, we know that we definitely have enough of a length to create a triangle. The case of the no triangle is when we don't have enough length. So first, again, we ask ourselves, is the opposite side greater than the adjacent side? In this case, we have 5. Is that greater than 10? Well, no, it's not. So then we need to go through and calculate h. h is going to be this adjacent side 10 times the sine of the angle given, which is 45 degrees. And if you take 10 times the sine of 45 degrees, you get approximately 7.07. So then you ask yourself, is the opposite side given, again, we're talking about opposite to the angle, is that greater than h? Well, in this case, is 5 greater than 7.07? No. So since we had no to both of these, we have no triangle. Finally, which is the most complex case, is the two triangles. And ultimately, you should know what shape you're looking for when you're dealing with applications. So you know which one of these triangles you're going to get, but the law of sines is always going to produce this bigger triangle here. And so we need to be careful with that. If it's possible that we want the smaller triangle that you see here in red, then we need to do a little bit of extra work to find that triangle. But again, in this case, you ask yourself, is the opposite side greater than the adjacent side? In this case, is 7 greater than 10? Well, no, it's not. So then you calculate h. And again, h is the minimum height. That's why this one didn't work. You needed this extra 2 feet or whatever it was to complete that triangle. It's not even going to be able to make a right triangle. H in this case is going to be 10 times the sine of the angle given, which is 35 degrees. So 10 times the sine of 35 gives us approximately 5.73. And so then we ask ourselves, is the opposite side greater than h? Is 7 greater than 5.73 in this case? Well, yes, it is. And since we have 2 answers, yes and no, we know that we have 2 triangles. And essentially what has happened here is that the minimum length you would need to create the right triangle here is that 5.73. And essentially what happens is you've got this side over here, which works, but you could also swing this over to the other position you see there, and that would still create a triangle with the same ratios. So what you do see here is that this creates what's known as an isosceles triangle. C prime here, this angle theta is equal to this angle theta. Both of those angles are the same. And so that's going to help us in finding the smaller red triangle. So let's go through some examples. Given that angle B is 105 degrees, side B is 16.5 miles, and A is 12 miles, we want to determine the number of triangles produced and solve the triangle if possible. And again, with this, I always like to draw the triangle so that the angle given down here, which is B, is 105. And I know I haven't really drawn that to scale. I can redraw that. Since we know this is an obtuse angle, we know this is going to look something like this. B is going to be 105 degrees. And side B up here is 16.5 miles. And then the adjacent side here is going to be 12 miles. So first question, is the opposite side greater than the adjacent side? In this case, is 16.5 greater than 12? Well, yes, it is. So we know that there is going to be one triangle. And now we're just going to use the law of sines. So I want you to pause the video here, use the law of sines that we learned in the last section, and find the remaining sides and angles of this triangle. So again, going through the law of sines, you should have found that angle A was 44.6 degrees, and then subtracting from 180, you should have gotten that C was 30.4 degrees, and then law of sines again to get that side C is 8.64 miles. Again, in this case, side C and angle C are the smallest, and those are opposite each other. Angle B and side B are the largest, and again, those are opposite each other. So this was just, again, a practice of 11.1. Let's look at what happens if we have either 0 or 2 triangles. This next example, if we are given that our angle C is 60 degrees, that opposite to that is 150 meters, and that our adjacent side is 180 meters. So that puts angle B down here, angle A up here, and side A down here. So again, first question, is the opposite side greater than the adjacent side? So in this case, is 150 greater than 180? Well, no. So we need to find H. H is going to be the adjacent side, 180 times the sine of 60 degrees. And this comes out to be 155.9 meters. And so now we ask ourselves, is the opposite side 150 greater than our h that we found, 155.9? No, it is not. So in this case, we have no triangle. Because we don't have enough distance, we need 155.9 meters to create a triangle. We don't have enough distance to create that triangle. So in this case, we have no triangle. We're done. Let's try this last example. So in this case, we've got angle B down here is 29 degrees, 45 minutes. This should be minutes, not seconds. And opposite B is 485.6 feet, and adjacent to it is 424.5 feet. So that puts angle C down here, A up top, and side A on the bottom. Now, first question, is the opposite side greater than the adjacent side? In this case, is 485.6 greater than 524.5? Well, no, it's not. So we need to find h. H in this case is going to be 524.5 times the sine of 29 degrees, 45 minutes, and that should be minutes. And we end up with 260.3 approximately. So we ask ourselves, is 485.6 greater than 260.3? Well, yes, it is. And since we have two answers, we have two triangles. So that's just the first part. Now we need to go through and find those triangles. So I'm going to start off over here on the left, and I'm going to go through the same process that we've done before with the law of sines. First angle we need to find is C, so we're going to take the sine of C, and that is going to be over 524.5. Compare this to the given information. We've got the sine of 29 degrees, 45 minutes, over 485.6. So again, sine of C is going to be 524.5 times the sine of 29 degrees, 45 minutes. Again, remember those parentheses, divided by 485.6. And we end up with 0.536 essentially. And to find C then, we are going to take sine inverse of that, and of that 0.536, and we are going to come up with, again, we're going to use the second answer option. So we've got sine inverse of second answer, and we're going to get 32.4 degrees. Okay, we want to convert that over to degree minute seconds. So again, we hit second angle, degree minute seconds, and we get 32 degrees, 24 minutes, 34 seconds. We'll just round this up to 25 minutes. We'll just stay with minutes here. Again, since that's over 30 seconds, we'll round that up to 25 minutes. And so then we can find angle A. Angle A is going to be 180 minus this 32 degrees, 25 minutes, and minus the given 29 degrees, 45 minutes. We end up with 117 degrees, 50 minutes. So this actually ends up being an obtuse angle, which you can kind of see up top, which makes sense. The last thing we need to do for this triangle is to, again, use the law of sines to get side A. So we've got A over the sine of that angle we just found, 117 degrees, 50 minutes, is equal to our given information, 485.6, divided by the sine of 29 degrees, 45 minutes. So A is going to be 485.6 times the sine of 117 degrees 50 minutes divided by the sine of 29 degrees 45 minutes. And we end up with approximately 865.4. We stay with the same number of significant digits that we were given. And units in this case were feet. So I'm not going to have as much room here to write our answers. I'm going to kind of try to make a space here in the center because we're going to have two triangles again. So for triangle 1, we know that angle A we found was 117 degrees 50 minutes. That angle B was given as 29 degrees 45 minutes, and that angle C we found to be 32 degrees 25 minutes. Side A we found was that 865.4. Side B was given as 485.6 feet, and side C was given as 524.5 feet. So we've got our first triangle here. I'll leave some room so we can fill in our information for our second triangle, and I will box this off so we can keep things separate. Now in this case, I'm going to kind of draw this picture up here again at the top, but I'm going to draw it slightly different. In this case, I'm going to draw it with the obtuse angle down here, and I'm going to call this C2. This is still B. The angle up here is going to be A2 because it will be different. This side here, 524.5, is still the same. This length here for 85.6 is still the same, and then this A2 here is going to be different. Now, if you remember, we said that essentially we ended up with this isosceles triangle where this angle here, which is C, is going to be this angle here, which is C. And this kind of like fits in right here. And if this is the case, then we can easily find C2 because it is the supplement of angle C. So C2 is going to be 180 minus the angle C we found before, which is 32 degrees 25 minutes. And again, that's because this triangle fits over here. We've got angle C, so then angle C2 would be the supplement because there has to be a straight line to get up to 180. We end up with 147 degrees 35 minutes. So now we have C2. That means we can find A2, and A2 is going to be essentially, now we're just following the same process that we did over here on the left hand side. We're going to take 180, we're going to subtract our newfound C2, which was 147 degrees 35 minutes, and then we're going to subtract our given angle of B, which was 29 degrees 45 minutes. So A2, so we end up with a very small angle, 2 degrees 40 minutes. Very, very small angle up there at the top, this acute angle up here, A2. And so in this case, the last step we need to do is we need to use the law of sines to find side A2. And so we would have A2 over the sine of the angle we just found, 2 degrees 40 minutes. And we want to, again, go back to the original information. We're comparing this to B. So B was 485.6. And we're dividing by the sine of 29 degrees 45 minutes. So A2 is going to be 485.6 times the sine of 2 degrees 40 minutes divided by the sine of 29 degrees 45 minutes. And we end up with A2 coming out to be approximately what? This is a length here. We come up with approximately 45.5. and our units again are feet. So if we look at triangle 2 here, then we have angle A2. Angle A2 was found to be 2 degrees 40 minutes. Angle B is still the same, so it is that same 29 degrees 45 minutes because it was given. And C2 we found to be 147 degrees and 35 minutes. Now side A we just found to be rather small, 45.5 feet, at least compared to the other two sides, which were given as B 485.6 feet, and side C is 524.5 feet. So those are our two triangles. This is probably a section that you want to go back and watch again to make sure that you understand what's going on. This can be a little tricky. Again, keep in mind that in application you wouldn't be finding both of these angles. You would just be finding one, but you know which one you're looking for. And so you'd have to be very careful, essentially, once you had found side C here, to switch over to this right side and to complete your process instead of finishing the process on the left. So this concludes the video for 11.2. Again, go back and rewatch this part if you need to. When you're done, complete the homework for 11.2 and then watch the final video for 11.3.